In physics, the electronvolt symbol eV, also written electronvolt and electronvolt, is a unit of energy equal to approximately 1.6 times 10⁻19 joules symbol J in SI units. Historically, the electronvolt was devised as a standard unit of measure through its usefulness in electrostatic particle accelerator sciences, because a particle with charge q has an energy E equals qv after passing through the potential V. If q is quoted in integer units of the elementary charge and the terminal bias in volts, one gets an energy in eV. Like the elementary charge on which it is based, it is not an independent quantity but is equal to 1 c square root 2h alpha, mu 0 c 0. It is a common unit of energy within physics, widely used in solid-state, atomic, nuclear, and particle physics. It is commonly used with the metric prefixes milli, kilo, mega, giga, tera, peta or exa, MeV, keV, MeV, GeV, TeV, PeV and EeV respectively. In some older documents, and in the name Bevatron, the symbol BeV is used, which stands for billion 109 electronvolts. It is equivalent to the GeV. Definition. An electronvolt is the amount of energy gained or lost by the charge of a single electron moving across an electric potential difference of 1 volt. Hence, it has a value of 1 volt, 1 J, C, multiplied by the electron's elementary charge E, 1.60217666208 98 times 10⁻19 C. Therefore, 1 electronvolt is equal to 1.60217666208 98 times 10⁻19 J. The electronvolt is not an SI unit, and its definition is empirical, unlike the liter, the light year and other such non-SI units, where its value in SI units must be obtained experimentally. Mass. By mass energy equivalence, the electronvolt is also a unit of mass. It is common in particle physics, where units of mass and energy are often interchanged, to express mass in units of eV, c2, where c is the speed of light in vacuum from E equals mc2. It is common to simply express mass in terms of eV as a unit of mass, effectively using a system of natural units with c set to 1. The mass equivalent of 1 electronvolt, C2 is 1 eV C 2 equals 1.602176646 times 10 minus 19 C 1 V 2.99792458 times 10 8 m s 2 equals 1.783 times 10 minus 36 kilogram display style 1 text ev c caret 2 equals frac 1.6021746 times 10 caret minus 19 text c dot 1 text v 2.99792458 times 10 caret 8 text m text s caret 2 equals 1.783 times 10 caret minus 36 text kilogram. For example, an electron and a positron, each with a mass of 0.511 MeV, C2, can annihilate to yield 1.022 MeV of energy. The proton has a mass of 0.938 GeV, C2. In general, the masses of all hadrons are of the order of 1 GeV, C2, which makes the GeV gigaelectronvolt a convenient unit of mass for particle physics. 1 GeV, C2 equals 1.783 times 10⁻27 kg. The unified atomic mass unit U, 1 gram divided by Avogadro's number, is almost the mass of a hydrogen atom, which is mostly the mass of the proton. To convert to megaelectronvolts, use the formula 1U. Topic 931.4941 MeV, C2. 0.9314941 GeV, C2. Topic momentum. In high-energy physics, the electronvolt is often used as a unit of momentum. A potential difference of 1 volt causes an electron to gain an amount of energy, i.e., 1 electronvolt. This gives rise to usage of eV and keV, MeV, GeV or TeV, as units of momentum, for the energy supplied results in acceleration of the particle. The dimensions of momentum units are Lmt-1. The dimensions of energy units are L2mt-2. Then, dividing the units of energy, such as eV, by a fundamental constant that has units of velocity, Lt-1, facilitates the required conversion of using energy units to describe momentum. In the field of high-energy particle physics, the fundamental velocity unit is the speed of light in vacuum c. By dividing energy in eV by the speed of light, one can describe the momentum of an electron in units of eV c. The fundamental velocity constant c is often dropped from the units of momentum by way of defining units of length such that the value of c is unity. For example, if the momentum p of an electron is said to be 1 GeV, then the conversion to mks can be achieved by p equals 1 GeV c equals 1 times 10⁹ 1.6021746 times 10 minus 19 c 1 v 2 99,792,458 times 10 8 m s equals 5.344286 times 10 minus 19 kilogram m s. Display style p equals 1 text GeV c equals frac 1 times 10 caret 9 c dot 1.6021746 times 10 caret minus 19 text c dot 1 text v 2.9979245 times 10 caret 8 text m text s equals 5.344286 times 10 caret minus 19 text kilogram c dot text m text s. Topic: Distance. In particle physics, a system of natural units, in which the speed of light in vacuum c and the reduced Planck constant h are dimensionless and equal to unity, is widely used. See h. 1. In these units, both distances and times are expressed in inverse energy units, while energy and mass are expressed in the same units. See mass-energy equivalence. In particular, particle scattering lengths are often presented in units of inverse particle masses. Outside this system of units, the conversion factors between electronvolt, second, and nanometer are the following: equals h 2 pi equals 1.054 571 726 47 times 10 minus 34 JS equals 6.582 119 28 15 times 10 minus 16 evs. Display style HBAR equals H over 2 pi equals 1.054 571 726 47 times 10 caret minus 34 m box JS equals 6.582 119 28 15 times 10 caret minus 16 m box evs. The above relations also allow expressing the mean lifetime tau of an unstable particle in seconds in terms of its decay width gamma in eV via gamma. Topic h tau. For example, the BO meson has a lifetime of 1.530 picoseconds. Mean decay length is c tau. 459.7 micrometers, or a decay width of 4.302 plus or minus 25 times 10⁻⁴ electron volts. Conversely, the tiny meson mass differences responsible for meson oscillations are often expressed in the more convenient inverse picoseconds. Energy in electronvolts is sometimes expressed through the wavelength of light with photons of the same energy. 1 electron volt equals 8065.544005 49 cm-1 equals. Topic: Temperature. equals. In certain fields, such as plasma physics, it is convenient to use the electronvolt as a unit of temperature. The conversion to the Kelvin scale is defined by using Kb, the Boltzmann constant. 1 K B equals 1.602 176 53 14 times 10 minus 19 J per electron volt. 1.380 6505 24 times 10 minus 23 J K equals 11 604.505 20 K per electron volt. Display style 1 over K underscore text B equals 1.602 176 53 14 times 10 caret minus 19 text J per electron volt over 1.380 6505 24 times 10 caret minus 23 text J K equals 11 604.505 20 text K per electron volt. For example, a typical magnetic confinement fusion plasma is 15 keV, or 170 mK. As an approximation, kBt is about 0.025 electron volts, approximately equals 290 K, 11,604 K per electron volt at a temperature of 20 degrees Celsius. Topic: Properties.
The energy E, frequency v, and wavelength lambda of a photon are related by E equals h nu equals h c lambda. Display style E equals h nu equals frac h c lambda equals 4.13566 7516 times 10 minus 15 eV s 299 792 458 meter per second. Lambda display style equals frac 4.13566 7516 times 10 caret minus 15 m box ev m box s 299 792 458 m box meter per second. Lambda, where h is the Planck constant, c is the speed of light. This reduces to E eV equals 4.13566 7516 FeVs nu phz. Display style E m box eV equals 4.13566 7516 m box FeVs c dot nu m box phz. equals 1 239
84,193 eV nanometer lambda nanometer. Display style equals frac 1 239.84193 m box ev m box nanometer lambda m box nanometer. A photon with a wavelength of 532 nanometers green light would have an energy of approximately 2.33 electron volts. Similarly, 1 electron volt would correspond to an infrared photon of wavelength 1240 nanometers or frequency 241.8 terahertz. Topic: Scattering experiments. In a low-energy nuclear scattering experiment, it is conventional to refer to the nuclear recoil energy in units of EVR, keVr, etc. This distinguishes the nuclear recoil energy from the electron equivalent recoil energy (EV, keV, etc.) measured by scintillation light. For example, the yield of a phototube is measured in Fe, keV, photoelectrons per keV electron equivalent energy. The relationship between EV, EVR, and EV depends on the medium the scattering takes place in, and must be established empirically for each material. Energy comparisons.
5.25 times 1032 electron volts, total energy released from a 20 knots nuclear fission device. 1.22 times 1028 electron volts, the Planck energy. 10 eV 1 times 1025 electron volts, the approximate grand unification energy. Approximately 624 eV, 6.24 times 1020 electron volts, energy consumed by a single 100-watt light bulb in 1 second. 100 W equals 100 J, s approximately equals 6.24 times 1020 electron volts per second. 300 eV, 3 times 1020 electron volts equals approximately 50 J, the so-called oh my god particle, the most energetic cosmic ray particle ever observed. 2 PeV, 2 petaelectronvolts, the most high energetic neutrino detected by the IceCube neutrino telescope in Antarctica. 14 TeV, the designed proton collision energy at the Large Hadron Collider, operated at about half of this energy since 30 March 2010, reached 13 TeV in May 2015. 1 TeV, a trillion electronvolts, or 1.602 times 10⁻⁷ J, about the kinetic energy of a flying mosquito. 125.1 plus or minus 0.2 GeV, the energy corresponding to the mass of the Higgs boson, as measured by two separate detectors at the LHC to a certainty better than 5 sigma. 210 MeV, the average energy released in fission of 1 Pu 239 atom. 200 MeV, the average energy released in nuclear fission of 1 U 235 atom. 17.6 MeV, the average energy released in the fusion of deuterium and tritium to form He4. This is 0.41 petajoules per kilogram of product produced. 1 MeV, 1.602 times 10^-13 J, about twice the rest energy of an electron. 13.6 electron volts, the energy required to ionize atomic hydrogen. Molecular bond energies are on the order of 1 electron volt to 10 electron volts per bond. 1.6 electron volts to 3.4 electron volts, the photon energy of visible light. 1 electron volt, the energy e.g. required to break a covalent bond in silicon. 720 MeV, the energy e.g. required to break a covalent bond in germanium. 25 MeV, the thermal energy kBt at room temperature. One air molecule has an average kinetic energy 38 MeV. 230 microeV, the thermal energy kBt of the cosmic microwave background. Topic: per mole. 1 mole of particles given 1 electron volt of energy has approximately 96.5 kilojoules of energy. This corresponds to the Faraday constant F approximately equals 96,485 cmol-1, where the energy in joules of n moles of particles each with energy x eV is x Fn. See also: orders of magnitude energy. Notes and references. External links. BIPM's definition of the electronvolt. Physical constants reference, CODATA data